Golden Iris Productions presents Light, Observers and Objectivity, a conceptual clarification of special relativity. Mark F. Dennis. In this presentation, we will clarify the meaning of Einstein's two postulates of special relativity and resolve a common confusion about how light behaves across different observers. The classical picture. In classical physics, we assume that objects have definite positions at definite times. All observers agree on what now means. Under this assumption, a photon is imagined to move along a path, occupying a well-defined position at every moment during its motion. Einstein's shift. Special relativity changes this picture in a fundamental way. Events themselves remain objective, but the separation of spacetime into space and time depends on the observer. This is the key conceptual shift introduced by Einstein. Two postulates. Einstein's theory is built on two postulates. First, the laws of physics are the same in all inertial frames. Second, every observer measures the same speed of light, denoted by c, regardless of motion. These statements reflect the structure of spacetime itself.
What this does not mean. The second postulate is often misunderstood. It does not mean that light has a single absolute velocity. There is no preferred frame of reference, not the source and not the observer. Instead, the statement is local. Every observer measures the speed of light at their own position and always obtains c. Worldlines. In relativity, objects are described by worldlines in spacetime. A worldline represents the full history of an object. For a photon, this path satisfies the condition ds squared equals 0. This is called a null worldline. Importantly, this path is the same for all observers. It is an objective feature of spacetime. The key problem. This leads us to a subtle question. What does it mean to ask, where is the photon right now? In relativity, the meaning of now depends on the observer. Different observers define time differently.
Relativity of simultaneity. This is known as the relativity of simultaneity. Events that are simultaneous in one frame are not necessarily simultaneous in another. So statements like, the photon is halfway there, only make sense after choosing a specific frame of reference. They are not universally defined. Two observers. Consider two observers detecting the same photon. One is moving toward the source, the other is moving away. Both measure the same speed of light, c. However, they disagree on time, position, and energy. These differences arise from their relative motion, not from any change in the photon itself. Is reality lost? Does this mean reality becomes ambiguous? No. The photon exists at definite spacetime events along its world line. What changes is how those events are described in terms of space and time. Objectivity is preserved, but it resides in spacetime rather than in space and time separately.
Prediction versus reality. We can still predict where a photon will be. But these predictions depend on the chosen frame of reference. Relativity allows prediction, but it does not allow absolute statements about where something is now without specifying a frame. Conclusion. Einstein did not remove objectivity. He redefined it. Reality is not based on absolute space and absolute time. It is based on spacetime and the worldlines within it. Once this is understood, the apparent paradoxes disappear. To be continued.